Okay, ladies. So this is a program that basically is supposed to simulate. I like to think of it as like an ecosystem. Okay, and what you're seeing here, this is the world. It's a two-dimensional world, and what we have these triangles and these squares. Now, to show you what happens if we slow this down, the triangles represent organisms. These are digital organisms that their job is to go move around the environment, eat the food. Now, the food are the squares. Okay? And their job is to go around, eat the food, gain enough energy, and reproduce. Okay? And what we're going to be doing with this, now this program, is we're going to be looking at the reproduction part. We're going to look at the difference between sexual and asexual reproduction. Okay? So whenever I said to you that it's easy to understand, like we can look at something, we can see that it's evolved, but trying to figure out why it evolved is really tricky. So we're going to try to figure out this is a big mystery in science. Why did sexual reproduction evolve? If you think about it, you as a female have to discard half of your genes when you make a baby, because when you make a baby, you're only passing on half of your DNA. The ultimate goal would be to pass on all of your DNA. Why wouldn't you want to contribute everything to the next generation? So there's a big cost to reproducing sexually. It's called a twofold cost. If you think about it, for you to get the same amount of DNA to the next generation, you need to have two babies. But if you reproduce asexually to get all of your DNA to the next generation, you need to only have one baby. So there's a big cost. You lose half of your DNA when you reproduce. So we're going to try to figure out, why did it evolve? Why did sexual reproduction evolve? So what we're going to, yes? Well, you're only passing on half of your DNA. But I got to ask you a question. You ever seen you ever seen male spiders reproduce with female spiders? Do you know that male is like way smaller than the female? Actually, I might have a picture of it. I think I might have a picture of it. Is it in the lecture hands here? Trade-offs in nature. I don't know how I remember where this thing was. So here. So you see this? That's a little male spider. You see this big gargantuan? That's the female spider. The male spider has to go up to the big scary female spider and see if it can mate with it. Now, why do that? Because oftentimes the female will end up eating the male. The reason why he does it is because if he doesn't, his genes die with him. His genes die with him. So the reason why this behavior, think about the whole idea of evolution, right? The variation, selection, time. Imagine that you were the variant that avoided females. Natural selection would wipe you away because you can't have what? Can't have babies. The whole point of it is to have babies, to pass on your genes. But you can only pass on half of your genes because you have to combine with another partner. So the whole goal of life is to pass on your genes. My question is, why wouldn't you want to pass on all of your genes? Why only half? So we're going to try to figure out why sexual selection evolved. So it's actually a very interesting question. So what you're going to do is you're going to use this program, and you're going to create a little world. Now, if you notice in your folder, there's also another file. There is a file with a link to a video that I created a few years ago about sexual evolution. Sexual reproduction. You can look at that at some point. But there is another file that is the input file for this program. Okay? So it looks like this. It says asex versus sex in your cobweb folder. So if you open up that file, like if you go to File Open and you open that file, you get these parameters. These are like the starting parameters for this program. So one more time. When you go to File, you got to open that data file and it inputs the parameters for you. Otherwise, you might not get those parameters, okay? So let me just give you a little tour here. This world is 80 by 80. There are actually only going to be 2 agent types. I'll show you, because if you look at the agents, there's a yellow, blue, green, and red. But I made the yellow 0 and I made the green 0, so you only have 2. You have blue and red. Okay? They are identical in every regard. Okay? They're identical in every regard. When they eat stuff, the way it works in cobweb, this is blue. So when it eats a blue square, it gets 100 units of energy. And when it eats any other color, it gets 25. But the red square has the exact same advantages too. So if you scroll down, everything is the same except for the reproduction. So when you look at it, the blue can reproduce sexually because it's set to 1, but the red can't. If you look at the asexual reproduction, the blue can't reproduce asexually, but the red one can. So the red is the asexual reproducer in this environment, and the blue is the sexual. If you want to flip that around, you go ahead and do that. It doesn't matter. This is their food. What you're going to be changing is the growth rate, how quickly the food grows. So this is set to a value of 6. If you increase it to 7, that means it grows more quickly, the food. If you decrease it to 4 or 3, it grows more slowly. Okay? So right now, this is our environment. We don't need this. Okay? So there are only 20 blues and 20 red organisms. But before we start, we need to, because I'm going to ask you to collect data. So what you're going to do is this. And this is all explained in the procedure. You're going to go to File, you're going to go to Log, and you're going to set up an Excel file. So I'm going to call this asex versus sex growth rate 6 dot XL. It has to have, you can call it, by the way, whatever you want to call it. You can just call it 6.xls if you want. Okay? But it has to have this .xls extension, otherwise it doesn't work. When you're doing it on the netbook, you might have to save it in your H drive, otherwise it might not allow you to save the data. Because I know there were issues in the past with the netbooks. So right now what I've done is I set up my environment, and I set up a spreadsheet that's going to collect the data. So now I'm going to run it. Now, the experiment calls for running it to 20,000 steps. I'm not going to do that here because it's going to take a little bit too long. I'm going to run it for a little bit. So right now, here's my environment. You can see that it looks like it's pretty much all red. So this is the little blocks, the food that's growing and disappearing. And my agents are running around looking for food. Okay? It is. So I'm going to stop it here. Now you're going to run it to 20,000. I've only run it to about 2,600. Okay? What this will give you, because we set up a data file, is a spreadsheet. Okay, this is my spreadsheet. And what you're going to do is you're going to graph the time. So I'm going to click on this column, hold down Control, and I'm going to click on Agent 2 and Agent 4. Yeah, keep holding Control. Now you can let it go. There's no Agent 3. It's Agent 2 and 4. Pay attention. So here's my graph. Okay? I can see this is my red agent, and this is my blue agent. Now, I'm only running to 2,500 steps, so I don't know what may happen over time. Okay? Because you got to remember, the sexually reproducing organisms have a hard time, because to reproduce sexually, what do you have to find? You got to find a mate. And if you're surrounded by asexually reproducing organisms, it might be hard for you to find a mate. So there could be a delay in how long it takes them to find something, but we don't know because I didn't run at 20,000 steps. Your job is to collect data from growth rates. So here we did was a growth rate of 6, but I want you guys to do growth rates for 6, but other ones too. Sorry, resources. Like we're going to try 7, we're going to try 5, 4, and 3. So if you look at your course outline, I set this up here. Okay, we're looking at the relative benefits of sex versus asex using cobweb. This is the procedure, but if you just follow what I just explained, you should be fine. What you're going to do is you're going to change the growth rate to 6 for all 4 types of food, and then you're going to change it to 5, 4, and 3. Actually, was it set to 6 already? It was set to 6, right? So actually, we're going to change it to 7. Okay, so you're going to do growth rates of from 3 to 7 is what you're going to do. Okay. Now, the interesting thing about this is you guys should get all the same results. You all should get the same results, and I'll explain that in a second. But then what we're going to do is we're going to change the experiment. The reason why you should all get the same results is because when you're running this program, the computer starts off with a certain brain. I'm going to call it a brain. Okay, it's programming basically. Okay, and this number corresponds to that program. So if everyone has the same number, then everyone's little digital organisms have basically the same type of brain. They'll do the exact same thing. They'll behave the same way. So, which means if you run the experiment, if Olivia runs the experiment and Petra runs the experiment, you should get pretty much the same result. We're going to do that initially. We're going to do the growth rate 3, 4, 5, 6, and 7. But then what we're going to do is I'm going to go back to the experiment and I'm going to change this. And how do you change it? Just hit this button. I don't care what number it is. Just make sure it's not the same number, which was 42. Okay? So you're going to reproduce the experiment by changing the brain or the programming of the digital organism. And then we're going to run it again to see if that changes the results. Okay? Now for the first run, it should be similar, but for the second one, it might be dramatically different. Okay? Now, what we're going to do is we're going to look at basically the amount of food. So one, you'll have environments that have a lot of food, and others you'll have environments that have little food. And we're going to see if there's an advantage for sexual reproduction in one environment versus sexual in the other one. So we're going to see if we can try to figure out where is the advantage for each of these types of reproduction. Okay? Questions? This is not due till after the March break, right? There's no way you're going to finish this before. Yeah?
So the initial count should be 20 and
Yeah, the initial count will be 20 and 20.
You're
2 and 4. Yeah. The only thing that you'll be changing initially is this, the food growth rate. Okay? We're going to go from 7 to 6 to 5 to 4 to 3. We're going to go from a lot of food to little food. And then once you do that, you're going to do it again, but you're going to change the artificial intelligence. You're going to change the programming. Okay? All right. That's it.